What's going on, everybody? This is Future Automation, a place where imagination meets reality, and you're listening to Tejas. So, guys, in this video, what we are going to see is we are going to see some basics of the world around Arduino. So, what is voltage, current, resistance, and some basic idea about jumper cables, its connection basics. What is the basic of breadboard? How we are supposed to connect using breadboard, two types of breadboard, and then we'll get an idea on sensors and actuators. So what is the work of sensors and actuators? So let's get with the basic. Before that, let's have a cup of coffee and let's get started. So, guys, thanks to Jason Statham, we do have a plan this time, that is again voltage, current, and resistance. Then we are going to see jumper cables and connection basics. We are going to have a breadboard basic idea, and then sensors and actuators. So, what are sensors? What are actuators? And their jobs? Let's start with some basics of what is voltage, current, and resistance. So basically voltage is something that pushes the electrons through the cable, through the wire, or through any conductive material. So if to be taken here, let me take a cable here. So don't worry about this, what is this actuator, just uh, keep an eye on this wire. So you can see here that now the electrons are moving freely here in this wire. There is no any current, there is no any voltage pushing it. Now if I'll add a current source to this connection, what it'll do is it will flow the current from here to here. So now the energy, or the the power that is pushing this electron through this wire is known as voltage. So voltage basically push the electrons through the conductive material. Now the amount of electrons that are flowing through this wire are nothing but current. Now current is measured in amps and voltage is measured in volts. So some of materials, like this copper in the wire, for an example, is a good conductor of electricity. Water is a good conductor of electricity. Salty water is very good conductor of electricity. So a lot of materials, all the metals are good conductor of electricity. Wood is a bad conductor of electricity. So some elements are good conductor of electricity, some are moderate, some are very bad conductors of electricity. Now a lot of times what happens is we want to resist the flow of the current. Say for example here an x 10, so say for example I'm giving an example. So we x amount of current is flowing through this circuit. Now what we want is we want to limit the current here. So we want to resist the current flow in this wire, and for that what we are going to do is we are going to use a resistance. Resistance is nothing but opposed to the flow of current. Now if you see this image here, you can see that what this guy is doing is voltage is trying to push ampere through this pipe, and this particular ohms, that is the the unit in which we measure the resistance, is trying to create a narrow, uh, what we can say, pressure here, so that it's getting hard for voltage to push the current through this pipe. That is what basically the uh, uh, resistance does. Now this is for all the noobs who are new to electronics or electrical, who don't have any idea about what is voltage, current, and resistance. So I have created this particular ppt in keeping in mind that everyone who is new to this field can also watch this. Now how are the resistors? So basically there are different types of resistors. If you'll see here, let me try to zoom in. uh, yep, you can see this is a normal resistor. You can see here we have different colors here. So resistors are identified by the color code. I'll leave the color code link in the description. I have not added that as part of ppt because again the ppt will become very complicated. I don't want to put that here right now. So you keep in mind that there are different amount of resistance that is being provided by different resistance. We have the resistance is measured again in ohms, kilo ohms. So we have have 10 ohms, 20 ohms, 100 ohms, 1k kilo ohm kind of thing. So these are the resistors that we are using. There is one more resistor that is used. I think in last video I have shown you there is a potentiometer that I use. So that is a variable resistance that we basically use. Now, moving on. So I think it moved a little bit fast. So, what are the measurement units for voltage, current, and resistance? So, basically, you can see here the symbols for each of them are I, V, and R, and the unit of measurements are ampere or amp, voltage for V, volt for voltage, and ohms for resistance, and these are the abbreviations. So, throughout the electronic work or throughout any kind of projects that you are doing in IoT, a lot of times you come across these kind of units, and you need to know what they are. Next. Now, jumper cables. So, basically, what jumper cables are, when you're creating a prototype project, the problem is that you cannot always solder everything and use it, because once you solder it, the board will kind of get a bit of, messy, and then you have to desolder again all the wires. So, to prevent that, they have made jumper cables. So, what jumper cables are? They are temporary connections that are being created, and then you can remove them anytime you want. So there are different types of jumper cable that we use. So I'll give you a first the types idea, and then we can go to the actual look at the jumper cables. So you can see here we have M to F, that is male to female, then we have female to female, and then male to male. Now there are two types of jumper cable. There are round male head and square female and square male head jumper cables. So let's move to the actual jumper cables, and you'll get an idea what is male to male, what is male to female, and what is female to female. Now if you'll see here, then you have kind of a pointy metal outside of this cable. So this part is known as the male header side. So this can be inserted into a female header pin to create a full connection for the electricity or the current to flow. Now if you'll go this side, you can see here that we have a female connector where we can insert a male header pin to complete the correct connection. Now these are male to female, sorry, yeah, so these are male to female connectors. You have the next, that is male to male connector. You can see both sides are having, so let me just, yeah. So you can see here there are both sides we are having the metal insert created added to this cable, so that's why it is a male to male. And then if you check this out, you can see for the both sides we are having the metal insert capability, that is we can insert the metal out heads to this. That is why this is the female to female connector. And these are it, guys. So these are the three types of jumper cable that we are going to use. So keep in mind, whenever I'm going to create a project, I'll be saying, let's take a male to male jumper cable, let's take a male to female jumper cable, or maybe I'll be saying let's take a female to female jumper cable. So you need to remember what are these type of jumper cables. Moving on, so we are done with the jumper cable. Now next part is breadboard basics. So breadboard basics is the most important part of any prototyping video, any prototyping project that you will be making. There are two types of breadboards. So let me just see if I have created that. No, okay, no. So I'll explain you that what are the types of. So let me take the Arduino on one side. Now you can see that the thing is, whenever you're creating a prototype project, you cannot always solder everything. If there is a big project or you are just doing a trial and error, so a lot of time what happens is you need a way to make sure that you're connecting everything, you're testing everything, and then removing everything back. Maybe it can be a reason that you don't want to solder everything, you're just trying out things, and you're then trying to prepare a model out of it, and then you are trying to uh, then you are trying to decide whether to go ahead or not. So for that, what they did is there are two types of breadboards that they have created. If you want to try a prototype project and you don't want to create the soldering mess, you use this kind of boards. So these are the boards which are known as solderless breadboards. You can see here that there are series of connections here in two different pattern. One is continuous connections, and then we have one in the blocks of connection. And if you'll see that these breadboards are created very, smartly. You can see here that we have different sockets at each end. Here you can see some are coming out, some are having insert sockets available this side and then this side. So this is because you can connect similar kind of breadboards ahead, and all the sides towards the all the side of this breadboard. So it makes sure that you can anytime increase the capacity of pins available for your breadboard. So now we have these two types of breadboard. One is soldered breadboard and one is solderless breadboard. For solderless breadboard, things are pretty simple. What you do is you start connecting everything here and then soldering from behind or from this side. So you connect everything this side and then you solder in this way. So the fashion is like the line you solder in together, that line will create one kind of connection. So you can see this side. So these are the lines. So this is basically now not connected to each other. Each of the square box, if I'll try to zoom in a little bit, and you can see here that each of the square box is a separate conductive uh, coating to this back non-conducting sheet, to make sure that whenever you are inserting something here, so say for example if I am inserting a connect a pin here, you can see that it is coming outside here. So what this does is you can sorry, I have done it wrong. So I'll do, yeah, we have to do like this. And whenever it is coming up on this side, you can solder it here. And if you want to create a connection from this socket to this socket, say, now let me try to, yeah. So you can see if you want to create a connection from this socket to this socket, then what you do is you solder from here to here, and these two are getting connected now. That's why it is called solder breadboard. Now let's go back a little bit. Okay, I'll keep it zoomed in only, because now what I need to show you is how the breadboard connections are connected. So this is a solderless breadboard. The major thing that you need to understand now in this, because this is the board that we'll be using a lot in throughout our projects, so you need to understand how the connections are made in this breadboard. So let me just take one jumper cable to show you. Now if you see that the pattern in the breadboard is slightly different towards the outside and then in the center. So these two are having similar kind of patterns with continuous insert sockets, but these are having different way of connecting. The reason is, if you will try to check how the connections in breadboard are connected, these lines, these straight lines are connected to each other. So if I'm connecting something here and I'm connecting something here. Sorry, I have taken wrong cable. Just give me a sec. Yeah. So, say for example, I have connected something here and then I have connected something here. So these two will always have a connection. So these two will be always connected, because the way the breadboards are constructed is these lines are connected with each other and these lines are connected with each other. And now, if we'll consider these lines which are at the end of the breadboard, they are connected horizontally. So if I'm connecting something here and if I'm connecting something here side to it, these two will not have any connection. It will short out the connection. So if we are connecting this here, then it will be connected. Now, usually these edges connections are used for ground and VCC. So this might be connected to VCC and this might be connected to ground. The reason is, you have, if say for example, you have 5 or 10 sensors that are connected, all the sensors will be needing 5 volts and ground or 3.3 volts and ground. So at such situations, since Arduino board is having very less amount of VCCs and grounds, you use this as a way to connect to the sensors. And now, since you have I got an idea on how the breadboard connections is, you need to make sure that there are different types of breadboard. Now some of the breadboards, what will happen is the breadboard is divided into half, so these lines are connected till here only and not from here to here. So you need to make sure that you need to check the description of the breadboard which is being used, or the pinout diagram of the breadboard that is being used by your end, to understand what exactly is the way of connection that you are doing. So let's move on to the next part, that is sensors and actuators. We need to understand what is the difference between sensors and actuators, because we are going to use them a lot. And if a lot of times the sensors and actuators terms might come in, you might get confused with what exactly they are. So let me keep these all things on the different side, and let's bring in all the sensors and actuators that I will showcase you. And don't think that these are the only sensors and actuators. We have for hundreds of thousands of sensors and actuators. I'm just showing you few for example. Okay, let me just take this light a little bit side because it is reflecting on the surface a lot. Okay, okay, so let me zoom in a little bit. Okay, I think this is enough. Yeah. Okay, so what are sensors? Now, sensor is a device that basically detects change and events in the physical environment. It may convert the physical parameters like, temperature, pressure, humidity, heat, motion into electrical signals. They may be analog or they may be digital, and then it will send that information to the board that you are using to, check or record or calculate that data, and then based on that data you can create different kind of actions. Now there are two types of sensors. One is active sensor and then there is a passive sensor. Now the active sensors are those who need an external power supply, and passive sensors are those which doesn't need any external power supply. They themselves create an electric signal. So one of the example that I do remember of a passive sensor is a piezoelectric sensor. So what exactly it does is, whenever there is a movement in that piezoelectric sensor, it generates electricity and sends an electrical signal. So the benefit of that is, it itself is an independent sensor that doesn't need any external power. But most of the sensors, again, they do need an external power because they have a lot of capabilities and abilities that are being uh, used out of it. Now, what are actuators? So, actuators are basically the devices that changes electrical signal into a kind of energy, you can say. So, for example, here this is an actuator. So, what it does is, whenever, say, for example, I'm detecting a motion outside my door, what I'll do is I'll send a signal to this sensor. What it'll do is it'll turn the electrical in energy that is coming into it, or electrical signal, and convert it into a mechanical energy by pushing this knob inside the door, and the lock will be inside this sensor and the door will be unlocked. So this particular actuator is known as solenoid lock. Then we have a stepper motor as well. So what it does is it converts the electrical signal into movement, that is motion. And this one is an electromagnet. So what it does is it converts an electrical signal into a magnet. And what it does is, so you can see here that it is having a different rating as well here. So 12 volts. What it will do is it can suck 15 kgs of weight from this. So this is what the power is. Now what you need to understand is, there are different types of sensors throughout the market. We have LDR, that is light dependent resistance. So it will change the resistance based on the light that is coming in. Then we have temperature and humidity sensor. We have ultrasonic sensor that I'm showcasing here. We have a vibration sensor. So what it does is it converts this vibration into digital electric signals, that is zeros or ones. Then we have a MQ7 carbon monoxide sensor. It reads the amount of carbon monoxide in the environment, and it gives you a an output. So we can get it in form of analog as well as digital as well. And we have a potentiometer to set a threshold throughout. So then we have many more sensors here. We have buzzers which are acting like a sound actuator which turns an electrical signal into a sound. Then we have say for example, this, what we can say, uh, RFID sensor, which is reading the RFID card. We have infrared sensor, we have LiDAR sensor, and many more actuators as well. We have solid state relays, we have mechanical relays. They are converting the electrical signal, that is a 5-volt signal, to complete the electrical circuit based on that. So if you want to control a 220-volt circuit through an Arduino, you need to use a relay module for that. And many more sensors we do have, like color detector sensors as well. So in future, whenever we'll start moving ahead, I'll add in more sensors, we'll create more projects from the Arduino. As of now, what I want to give you is a basic idea on what exactly sensors and actuators are. So I have shown some of the types of sensors. Now different types of sensors. Now what are actuators? So we have different types of actuators as well. There are hydraulic actuators, there are pneumatic actuators, there are electrical actuators, then there are thermal actuators, and then there are magnetic actuators as well. So this is one of the example. The solenoid, this lock is an example of magnetic actuator. This is again a magnetic actuator as well. So, and these are the electrical actuators. So they are basically converting the electrical signal into a motion with the gears and all that stuff. So these are some of the types of actuators that we are having, and we are going to use all the possible sensors and actuators throughout all the projects that we are going to do. And by the end of this video, I hope that you have got an idea of what kind of sensors and actuators we might come across, and what is actuator or what is sensor, what is volt, current, and resistance, because we are going to come across all these terms throughout the different videos of IoT. But again, every time I have something that comes up in the video which is new, or maybe you might have forgotten, I'll surely explain all the things in short and make sure that you remember everything. So yep guys, that's it. That's all for today's video. This was all the basic world around the Arduino, and thank you everyone for watching this video. And if you like this video, make sure you hit the like button, share it with everyone, those who are IoT enthusiasts. And if you are new to my channel, make sure you hit the subscribe button. All the queries and all the issues that you are facing, make sure you are adding in the comment box, because I am trying to reply to all the comments which are coming in my comment box, to make sure that all the queries are solved. Thanks for everyone who is watching the Apple Shortcuts videos, because those videos are blasting the internet right now. All the videos are going really great, and I think most of the videos are already crossed 1K views. So that is really a good playlist that is going on. I have created a playlist. I'll leave the link in the description for all the parts that I have shown you. If you want to buy them, I'll link their link as well in the description. So make sure you go check it out. And if you are interested in doing something, buy a basic kit of Arduino, and do make sure that you are trying out everything, because without trial there is no any IoT. So although without trial there is no any project, of course. So make sure you try everything. And this is it guys. Keep innovating. Take care. Thank you.